For the first part, we will introduce the RSDB update. So now let's see the RSDB update. So here we can see for the RSDB update mechanism, each RSA actually in our RSDB has an SN number. So the SN number actually is consisting of 33 bits. So we will know the range of our SN range is from the it's 00001 to the 7FFFF. Okay, the range between the two values we can use to mark our RSA information. Okay, and for the OSPF router, actually we will flood the RSA information to every router, and the time is every 30 minutes. We have to flood the RSA information. So actually the flood's function is to ensure RSDB synchronization. We have to make sure every router has the complete RSA information, has the complete RSDB. Every router has the same RSDB information so that they can use their RSDB to calculate the routing table by themselves. Okay. So each time RSAs are flooded, the SN increases by 1. So it means maybe now the RSA information, the SN number is 8000001, and now we flood the RSA, right? And the newest RSA will add the 1. So it will become the 2. It will become the 2. Okay. So we will increase the SN number when the RSA flood. So now let's see the mechanism of the RSDB update. So first, one router received an RSA. And after we received this RSA, we have to compare the entry in our RSDB. So the RSDB will compare the RSA information in our RSDB, and then we find maybe in our RSDB we don't have this entry, maybe we have this entry, right? So if we find we don't have this entry and we have to add this entry to the database, and after this we will send the new RSACK packet to the neighbors, because the neighbor sent the RSAU packet. We have to reply the RSACK to the neighbors. After this, flood the RSA to other neighbors, because we know we got the newest RSA information. We have to do the flood. And then every router receives the RSA and completes the RSDB. And for the complete RSDB, every router have to run OSPF algorithm and calculate the new router and generate the new routing tables. So this is the RSDB update mechanism. So now, if the RSDB finds I have this entry, right? I have this entry, so I don't need to update my RSDB. I don't need to complete my RSDB. I don't need to flood this RSA information to other neighbors, right? So after this, and next step is the SN the same as that's the local RSA. So actually we have two choices. It's the same and it's not same. So for the SN number is the same, so we just can ignore the RSA because we have the newest RSA information, right? So if we find the SN number is different, so next step we have to compare the SN number. We have to compare the SN number. So for the SN number, actually the SN of the local RSA is smaller, and we find the local RSA is smaller. It means the RSA we received is the newest. So we have to update the RSDB. So of course, we are from add the entry to the database and send the RSA packet to the neighbor and flood the RSA to other neighbors and the run SPF to calculate the new router. We have to do all the process here because the RSA's SN number is bigger than me, right? So we have to update the RSDB. If we find is the SN of the local RSA is bigger than the RSA which I have received, so I have to send the latest RSU packet to the sender. It means I have the newest RSA information, so I have to send the RSU packet to help you to update the RSA information so that you can add the newest RSA into your database and send the RSA packet to me and flood the RSA information to your neighbors and then run the SFPF algorithm to calculate the new router and generate the newest routing table. So this is the OSPF RSDB update mechanism. So for the last, we can see when the SN reaches the master value, so how can we do? So now the router can send an RSA with age marked as 60 minutes. So we know in common the RSA will flood every 30 minutes, right? But after the neighbor receives such an RSA and the age is 60 minutes, so the router deletes this RSA from the RSDB and then the SN changed to from the beginning value. Okay, and then after we receive is the SN or the newest RSA, we increase the SN number by this value. Okay, so this is the mechanism for RSDB update. Okay, next. So for the OSPF basic principle, we have finished all the instruction. And now we will do some practice question. And after the practice question, we will do a summary. So for the first practice question, it's a single choice question. As a link states routing protocol, which of the following statements about OSPF characteristics is correct? So the option A is the OSPF router periodically floods its own router information. And the option B is the OSPF router floods its own link states periodically or when tracked. The option C is a single router cannot obtain the topology structure in an area. So the answer we can see it's a B. It's a B, right? Because the OSPF router floods its own link states, lots the routing information. So we have the RSA information and build the RSDB and then use the RSPF calculate the routing table, right? We not receive the routing information directly from our neighbors. Okay. And next is a single choice. The question is when OSPF is enabled on two routers, they can establish a neighbor relationship so long as the hello packet matches. So the answer is true. We use the hello packet to build the neighbor relationship and to maintain the neighbor relationship. We have to keep the 7 fields to follow the rules actually, so they can build the neighbor relationship successfully. Okay, and next is a multiple choice. So this question is which of the following are not OSPF packets? First is the hello, and second is the DR, and third is the RSDB, and next is the DBD. And we know in OSPF packets we have 5 types, right? The hello, DBD, RSR, SU, RSACK. So here the answer is a B, C. We don't have the D. R packet. We also don't have the RSDB packet, right? Okay, next question is which of the following in the hello packet are the causes for OSPF neighbor establishment feature? So before we have introduced, we have followed the 7 fears rules, right? So here the answer is the ABC. The different route IDs and the different areas IDs, the different subnet masks on the Ethernet, and the different network tabs. And of course, we have to keep the step ID to be the same. We have to keep the authentication tab to be the same. We have to keep the authentication password to be the same. Okay, this is the rules we have to follow so that we can build the neighbor relationship successfully. And next is which of the following OSPF network tabs do not need DR/BDR election. So here, the option A is the broadcasting network. The option B is the NBMA network. The option C is the P2MP network. The option D is the P2P network. So here we can see the answer is the P2MP and P2P network. Because in the multicast network, we have to elect the DR, BDR, and DR other. Okay. But for the P2P and P2MP, we don't need to elect the DR and BDR. So the last, we will do a summary about today's class. So OSPF uses the SPF algorithm, which is loop-free. It means in the OSPF, we don't consider the loop problems because we use the SPF algorithm. Actually, for the SPF algorithm, we receive the RSA information from the neighbors. So for the neighbors, we just exchange the RSA information between each other, not the detailed routing information between each other. For the every router, we'll have the detailed RSA information, and then we will build the complete RSDB. And for the RSDB, we will use SPF algorithm and to calculate the routing table by every router. Okay, and the second is the routers running OSPF transmit link state information to calculate routes by exchange 5 types of packets. So we use the hello packet to establish the neighbor relationship, to maintain the neighbor relationship, and to keep the neighbor relationship. And the second actually is the DBD, right? We use the DBD to elect the master and slave. We use DBD to exchange the RSA list information and to find which RSA I don't have, to compare the RSA list. And we also use the RSR to request which RSA I don't have. And I use the RSU to answer the RSR to send the detailed RSA information to our neighbors. And after we receive the RSU, we use RSACK to reply the RSU packet. And to tell our neighbors, I have received the newest RSU information, and I will update my RSDB. I will add the RSA entry into my RSDB. So this is a 5 types packet. And then the OSPF runs on different data link layer protocols to automatically adjust the OSPF network type of an interface. So in the network, actually, the data link layer have many types of protocols like the PP, HDRC, like the frame relay, like the Ethernet, like X.25. So for the different data link layer, we have to adjust our OSPF protocol to become the different network types. For example, the P2P and the P2MP and the broadcast and the non-broadcast multi-access. So for the different data link layer, we have to automatically adjust the OSPF network tab. Okay, so the last is the DR-BDR election mechanism optimize the RSA flooding on the broadcast network to save bandwidth. So actually for the OSPF, we know it's very famous in the industries. So the OSPF also has some problems in our network. So we need to elect the DR-BDR and we need to do the area division. So for this action, actually, it can help us to management and optimize the OSPF mechanism. And for the DR-BDR, can optimize RSA flood on the broadcast network to save the bandwidth. Of course, we also can use the area division and to control the RSA flood. Of course, to decrease the RSA entry or the number of our RSA entry in RSDB. So also the area division can help every router work better. So this is the OSPF basic protocol. Thank you for watching.